The go statement runs a test step, which is a sequence of subintervals. The interface into the underlying Ivy engine takes a single character string as an operand. So from an Ivy script outer wrapper programming language point of view, the go statement has a single operand, which is a text string. The parameters within that are internally parsed within the Ivy engine go statement machinery. The length of each subinterval is specified by the subinterval seconds parameter, which defaults to 5 seconds. Incidentally, if you have a case to measure a restricted set of things much more frequently, we can talk about putting in support, but 5 seconds may already be pretty fast if we're talking about collecting from large subsystems with tens of thousands of LDEVs. We'll see. And most of the time, 5 seconds is plenty short enough, as it'll be enough variability from subinterval to subinterval anyway. And so you just need to see enough IOs overall to be able to judge what the average is going to be. And it doesn't really matter if you do those number of IOs in a bunch of short subintervals or a couple of long subintervals. So what I would say is you probably wouldn't want to make it shorter than 5 seconds. And actually, if you're doing tests that run for long periods of time, you might want to run with much longer subintervals just to make the CSV file smaller. A test step, a subinterval sequence, is judged to be either a success or a failure. And if you do not use the measure equals on feature, then the number of warm-up subintervals and the number of measurement subintervals will be computed from the warm-up seconds parameter and from the measure seconds parameter. If you are using measure equals on, described in a later presentation, then the warm-up period must be at least as long as specified by the warm-up seconds parameter, and the measurement period must be at least as long as specified by the measure seconds parameter. And there must be at least one cooldown subinterval. For each test step, you get a subfolder of the overall test output folder that contains the CSV files that have one line for each subinterval within that subinterval sequence or test step. Then, within the test step folder, you get nested subfolders for each workload data rollup, and in those, there'll be a CSV file for each rollup instance, and in each CSV file, there'll be one line per subinterval. And then also in the test step folder, if you have a command device, there'll be a subfolder to contain RAID subsystem RMLib API data. And this is collected time synchronized. It's collected so as to be as fresh as possible at the end of each subinterval. And then for each test step, if it is a success, then there will be an output line printed in all of the summary CSV files in the root folder of the Ivy test run. Cooldown runs for at least one subinterval, and by default, the cooldown by write pending parameter equals on. What the cooldown by write pending parameter does is it runs for one subinterval, and then if write pending isn't empty, it sends out IOPS equals 0 and runs for another subinterval, etc. And then finally, when write pending is empty, then cooldown will be finished. You can turn cooldown by write pending equals off if you know that you're going to run the next test step and it's going to put objects of exactly the same type into write pending as the previous step did. In that case, it's reasonable to carry forward the items that are heading for the exact same destination as the next step. So this can speed up the next test step as long as you're putting the same kind of objects in the same place as you were in the previous test steps. Okay. The default go statement is just go semicolon, and in that case you'll get 5 warm-up seconds. You'll get 60 measure seconds with a subinterval seconds equals 5 length of each subinterval. And then if you have a command device, it may continue to run more cooldown subintervals if cooldown by write pending was on, and write pending is not empty. So this default go statement is useful if you're developing an IvyScript workflow and you just want to see some sample CSV files to see what data you get out. If you're running a series of test steps iterating over something, then it's advisable to create a step name which describes the iteration that this step is in the overall loop. So if you're iterating by block size, you might want to say block equals 4K or something like that. You can use string expressions in the IvyScript language to build the overall string that you pass to the go statement. So you can use any kind of an expression to build the step name in a meaningful way. It's very handy when you make Excel charts, as the step names are by default what label the bars or label the series or whatever in the charts, or that get labeled as to in a response time histogram. Each test step you'll have the label in the response time histogram that's taken from the step name. So giving it a meaningful step name is what you want to do if you're iterating over something in a loop. That's it for the go statement. That's it for the default form of the go statement, where it runs for a fixed number of subintervals and stops.